4-meter long, you can see the 4 meters here, water tank, open at the top, is in the shape of a triangular prism. The triangular face is a right isosceles triangle, as we can see here, with congruent sides of 1 meter length. Initially, the tank is completely full of water, but it develops a leak and loses water at a constant rate of 0.08 cubic meters per hour. This is telling us that dV dt is 0.08. Let H equal the depth of water in meters in the tank after T hours. We can see H just here. We can see that it's that. Show that the volume of water in the tank, V cubic meters, is given by the expression V is equal to 4H squared. Well, it's a prism, so we know that the volume is going to be the cross-sectional area times the length. And let's think about the cross-sectional area. So let's have a look at that right triangle. So we've got a right angle here, and there's the hypotenuse, and we know that this is h. And of course this angle here is pi by 4. So let's just call this x for the moment. And we know that this is the opposite and this is the hypotenuse compared to this angle. So the sine of pi by 4 would be equal to h over x. So x is going to be h over sine pi by 4. So x is going to be h root 2. Now this means that that's also x, and this is the base and this is the height of this right angled triangle. So the cross-sectional area is going to be a half times the base times the height, which is equal to, because root 2 times 2 is 2, divide by that 2 is just equal to h squared. So the volume is going to be h squared times the length, which is 4, which is 4h squared, as required. So we now want to determine the rate of change of the depth. So that's dh dt. Well, we could do that as dh dv dt, since we know dv dt. Now dv dh is going to be 8h. So dh dt, being dh dv, is 1 over 8h multiplied by dv dt, which is 0.08. And we can see that that gives me 0.01 over h. And we want to evaluate this when h is 0.6. So dh dt, given that h is 0.6, is 0.01 over 0.6. So 0.01 divided by 0.6 is 0.016 recurring, and that would be in meters per hour. Now at this stage it's just the water's leaking out, so of course this should have been a negative up here, so dv dt is negative 0.08, and so this should have been a negative here, negative, negative, and of course that's actually negative there. Okay, so that's corrected that. It's always a good thing to just look at your answers as you get them and just make sure you haven't done anything like that. Assume that the rate of leakage stays constant at 0.08 cubic meters per hour. Show that the differential equation that relates dh dt with the depth h is given by dh dt is equal to negative 1 over 100 h. Actually, I think I got that in the last part, just here. So I'm going to reference that as 1, and so I'm going to say reference 1 in part B, where I have dh dt is equal to negative 0.01 over h, and that is of course equal to negative 1 over 100 h. Hence, determine the relationship for the depth h at any time. So dh dt is negative 1 over 100 h. So that means that 100 h dh is going to be equal to the integral of negative 1 dt. So that gives me 100h squared over 2, or 50h squared, is equal to negative t plus a constant. Now when t is equal to 0, this trough is full. So right to the brim here, well that's 1, that's a right angle, and this is h, and that would make that a right angle. Because we know that this is pi by 4 radians or 45 degrees, this is isosceles, so this is also h. So h squared plus h squared equals 1. So 2h squared equals 1, h squared equals half. H is equal to 1 over root 2. So h is equal to 1 over root 2 when t equals 0. So that would make h squared half, as we said there. So that would give me 25 is equal to c. So 50h squared is equal to 25 take away t. So h squared is going to be 25 take away t over 50, and therefore h is going to be the square root. It has to be the positive square root because it's a distance. Take away t over 50.